This video is about periodic trends. So the keyword in the question is asking for us to complete the following reactions, which are these two reactions down here, and to state the observation of the result of these reactions as well. So the concept is the displacement reaction between halogens. Here is the group halogens, which is group 17. So we have fluorine, chloride, bromine, and iodine, etc. And as we go up the group, there's an increase of electronegativity. And this is due to, so let's take fluorine, for example. It has the least electron shielding effect, which means it has the most nuclear attraction force, and it is therefore the most likely to gain an electron. This would mean it is more reactive up the groups as well. Here's an example reaction. If we have fluorine 2 plus Cl negative, so Cl negative, it's actually the same as, for example, the molecule NaCl. And this is because Cl in the molecule NaCl still has a charge of Cl negative 1. And so the sodium in this molecule is what we call a spectator ion, where it is there, but it's not involved in the reaction, and we can just simply ignore it and focus on the halogen in the molecule. Fluorine is above chlorine in the halogen group, and so fluorine is more reactive than chlorine, and so a single displacement will occur. Fluorine will displace chlorine because chlorine is in possession of an electron, and chlorine will displace chlorine to take that electron. The result would be fluorine negative plus chlorine 2. We were to have another example where we have the opposite, so we have chlorine 2 plus fluorine negative. So fluorine is more reactive than chlorine, as we already indicated, but here fluorine is already in possession of the electron, so it's already achieved its desired outcome, so therefore no reaction will occur. Going back to our first example, so the element that has been displaced, so the element with the 2, so like Cl2 in the example, is in gaseous state. But with the exception of bromine, because bromine is actually in liquid state in room temperature. Also, the element that's been displaced has a color, so Cl2 has a color of its own, whereas Cl negative is colorless, so we actually expect a color change throughout this chemical reaction. So in this table, we can see the halogens and their colors. So again, fluorine, chlorine, iodine is in gaseous form, and bromine is in liquid form. So we can see fluorine has a a pale yellow color, chlorine has this green, bromine has a yellow/orange color, iodine has a dark red/brown. And you just have to memorize these colors. But our study tip is that you don't have to remember the color of fluorine because fluorine is the most reactive, so it will never show up as pale yellow in a chemical reaction. Going back to our question, we have firstly chlorine plus potassium bromine. And remember, potassium is a spectator ion, so we can simply ignore it and focus on chlorine and bromine. So chlorine is more reactive than bromine. So chlorine would displace its bromine, and we would have the result of potassium chloride in aqueous form plus bromine by itself, so Br2, and it would be in liquid form because bromine is the only halogen that is in liquid form. And now second reaction, we're looking at chlorine and iodine, and again chlorine's more reactive, so we have potassium chlorine aqueous form and iodine in gaseous form. The observation for the first reaction would be something like a yellow/orange solution is formed due to the formation of bromine. But the observation for the second reaction, there's actually two. So one is a dark red-brown solutions formed due to the formation of iodine, as well as a formation of bubbles due to the formation of iodine gas. And that is our final answer for this question.